Hello guys, the purpose of this workshop is very simple. I have been asked by my student on the Udemy of Mastering ANSYS CFD Level 2 course that he is getting the issues in this meshing of this file, and this is what I achieved with the surface mesh first and then the volume mesh. And usually what I do is that I create the volume mesh using the octree method, and then I delete the volume mesh. I just refine the quality of the mesh, and then I go to the create mesh or compute mesh, and from here I choose a quick Denali method. And first it was a robust, and then second step is the from quick Denali. And why not with the octree? Because the octree produces the mesh of the ratio 1 to 2 or 2 to 4. So every time the ratio is of every second element is the 2. And this will create the large jumps in the mesh. And secondly, depending on the size of the mesh of local elements, the size may remain to the lowest size or may increase to the higher value. And in both cases, if the size is too large, if the size is too small, the mesh will be very, very coarse, and mesh may be very, very fine respectively. And the second thing is that why I am doing this thing is that it's a general practice, a general question, and you encounter most of the time in your ICEMCFD meshing when you work on tetra module of the ICEMCFD. So I wanted to give you some very detailed overview of tackling these problems in ICEMCFD. Now, first of all, for any meshing to work on the any model, the first requirement, the basic requirement is that the geometry of that particular CFD model should be of the high quality. And from this model, I can easily see that the problem lies in the geometry, because I had been working on this model for the last 3 days, and the file which I provided in my Udemy course is slightly different, and it does not have these problems. So definitely I cannot say that you should always be using my model, which I work with a very fine setting. So you can work with start with any model, and you may end up with any problem on the fly. So on your way you can encounter any problem. So the approach should be, our teaching should be in a way so that you can learn, and you should be able to rectify problems on your end. So therefore this is the purpose of this workshop. And now this is the mesh which I have after going through the every step. And this mesh I created is the first surface mesh from the meshing technique is known as shell meshing. And here I choose the alt try, and method was page independent. The page independent works in the same way as the octree mesh for the volume meshing. And if you click on respect line elements, this is the technique or command you apply. For example, you are just want to recreate the mesh of only this blade. And definitely, so in the neighboring part we have some upper boundary, and this green in the color in the bottom boundary. So definitely the mesh should be shared, and the number of nodes on this surface when it meets on this surface or maybe on the top side, the mesh number of nodes should be same, and secondly they should be connected to each other. And this is the when we use this command aspect line elements. But since we are going to mesh all the parts, so it does not mean anything here. And then I will show you the file which I received in my email. And this is the file which created problems for multiple days, couple of days. So first of all, I would be commenting on the few things here. First, show the model in the surfaces. And first thing I can notice is that I used the topo tolerance of the point 0001. And why? Because if the size of any element which is shown here, the mesh size should be 1/10 of the minimum size of the mesh in the geometry. And now you can see that even if you go for the 1/10 part of topo tolerance, even the minimum size in the domain is 0.0005, and here the topo tolerance is a 0.0003, 0.005, 0.003, and which is almost same. Maybe you can say it's twice of this value. So there is no factor of 10 here. So therefore, I would be recommending this. You should be using the topo tolerance of the 0.001 in this case. And second thing, from here you can check the size of this tolerance is very simple. Now you can see that the minimum size of any surface or smallest surface is this one. And if I hide the surface from here and go to this measurement tool here, and roughly speaking, it's not a straight line, but roughly it's a straight line, or maybe here, you can see the size is a 0.001. And again, if this is the element size, if I just put the one element across this whole length, this whole width, the size would be of the mesh would be the 0.001. And again, the rule of thumb says that the size should be 1/10 of this minimum size, which is the 0.001. Okay, so what will happen if I put this size and I go to geometry, and from geometry I use build topology. Build topology is used to create the basic purpose of build topology is that it will check the model that if there is any leakage of geometry or not. So if you get all the curves in the red color, it means geometry is watertight. There is no leakage of geometry at any location, or it shows that the mesh size is not smaller than the geometry size which we have in the model here. So if I run this thing, I can see this is a green color, and green color shows this curve is attached to only one single surface. But on the contrary, you can see this is attached to the two surfaces. The one is over here, second is over here. So it means that there is an issue of tolerance here, and therefore what I'm doing is that I'm just clicking on undo, and then I'm going to delete this surface from here. I would be hiding the other surfaces in this way, and then I will be looking for the points. So I would be looking for the points. So let's say I create the 2 points. One point is a 50% location, which is here, and second point at the 0% location, which should be somewhere here. And before that, because I want to work on only these two curves, so I would be putting the other curves in separate part. So let's say create a part name as a curves and others. So I would be putting these parts over here, and if I click on this command, which is a toggle between all and partial enclosures, so I can select these curves without going without putting them inside the box, and now I can hide them from here, and then I would try to put these parts also, which are here. But this time what I'm doing is that I should be hiding unchecking the option for the points and surfaces and also bodies, and uncheck this option as well, and now I can use this whole box, and still I not be able to use select these curves from here. So I can select these curves which are smaller here, and this internal curve as well. Now I must be checking which surface I want to use here. So it should be inside. It should be inside. So this should also be part of this geometry. And similarly, these parts. And these parts. Okay, similarly, I am going to create the part for the all points here. PTS should be enough for the part names for the point, and use this command to select all the visible and invisible objects for the points, and undo. So I should be unchecking the option for the crossing the option for the curves and select the option for points, and once again save this file. And also again right click on the curves other and add to part, and add this curve also to the geometry. All right. And the one more important thing is that I would create the new part, which is my fluid, and put this body inside this part. And now hide these parts here and also the points, and again save it. All right, so now I'm going to create these points. Okay, so the first point, second point over here, and for the bottom curves, because there are two curves, so I'm going to create the two endpoints and they will be just below each other. And the one more point I would be creating over here, and also on the other side. And then I will project these points on this top curve here, these 2 points. So again I got these 4 points here, and now we can delete these points one by one, these curves in fact. And I'm going to create the curve from the 3 points. The command is over here, first, second and third. And similarly for these 3 points, and then on the bottom side. And the order is very important. These points should be selected, and these points. So it may not be like that if we select these points, 3 points and 3 points, so we get the curve here. But if we select the first, second, third, the curve will be with these 3 points. So the bottom and top, they should have the same sequence, and therefore they should be parallel to each other. And now choose the line command and create these 2 lines. And now I'm going to create my surface, and the part name would be the same part name, which is wall small. If it's not there, then I can put the name here. It's a wall small, and create. And tolerance I'm going to provide is a 0.401. First surface and second surface. Okay. Okay, now again I will try to run the build topology once again, and hide surfaces. Now I can see these all curves are in the green color, including these curves over here. And as you can see that we have now these all curves, they are in the red color, and this shows that now these curves, they have the 2 common surfaces and for each curve. And definitely if you take a look on the scheme of this geometry, so every curve should have the 2 neighboring surfaces. For example, here on this curve, the neighboring surfaces are the wall small and the inlet. And if you see on surfaces, you can see that the surfaces, they have somehow there's some gap here, which is a visual effect. And if you right click on surfaces and click on show full, this will be okay. So what we did here, that we changed the topo tolerance to the 0.401, and this is because if you take a look on the mesh size, The minimum size we are having is a 0.004, and the minimum size of the geometry is 0.001. And to be on safe side, I use the value of triangulation tolerance as a 10 power minus 5, and turbo tolerance, this is triangulation tolerance of this geometry quality, and turbo tolerance is a 0.401 to be on the safe side. So that the geometry should not have any leak from the where we mesh can leak to the outside, and secondly the element should not jump from the one surface to the second surface. And next thing is that which I'm setting here. So just let me hide the few surfaces from here, and these surfaces are all small and the inlet, so that I can take a look on the settings from the inside. The second thing I did is that I use the size, global element seed size, which is the maximum element seed size, is equal to the 0.01. And what is the meaning of the global element seed size? This is the maximum size we will get in the volume when we use the octave method. And this does not mean that the size cannot go to the lower value. Size can be of the lower value, but this is a limit on the maximum mesh size. So this is a cap on the maximum side, and the mesh size cannot increase beyond this value. And usually speaking, when you set the size on all these surfaces, so this will be influenced by the sizes of the surfaces in the volume size. And just a reminder for you, the octave starts with a one big triangle that cover all the geometry, and then it divides up to so that the algorithm inside the meshing software, this will capture the geometry features, and after that this will start to again go back and move forward to the volume, and then this will be stopped when the maximum size is achieved inside the volume anywhere. So this is the thing we are going to do. And just take a look on these sizes. So for the two sides of the blade, which is leading edge, trailing edge, the size is 0.002, 0.002, and tetra size ratio tetra width is 1.2 and 1, which I think you have already said it. But this is just to be clear, this is a ratio of the volume elements that they will grow from surface. After surface, the ratio of 1.2, and tetra width means that the first element size after the surface, they will have the same size as the size of the elements on this geometry itself. So the first layer will be definitely will be size of the surface, and second layer, which is tetra width, will be of also same size, and afterwards size will grow at the ratio of 1.2, and by default the growth ratio for the octave is 2, and eventually this will stop at the maximum size. And also we have the prism setting for these three boundaries, and these three boundaries are in fact this is the geometry for the blade itself, the main part, the two leading and trailing edge parts. So this is what we do here: apply and dismiss. And next thing is that we define the H criterion. So by default it's a 0.02, just 0.2, and I change this value to the 0.05. And why? So just take a look on the one lecture by the ANSYS on the ICEMCFD on the volume meshing. And if I search that command, that is the H Criterion. So in the H criteria, we have the option. Let me search. So it splits the element at the factor greater than the set value to better capture geometry. So definitely this is a problem we are getting and this is the main issue from where I started to look for the solution. And then I come up with many things in the model. These are the geometry capturing. Geometry was not good at some boundaries, so I just recreated geometry from curves. And then I defined the sizes on the different parts and the maximum element seed size in the volume. The next thing is the H criterion. And if we go further, you can see that this is what is happening. So let's say if the element size is something we said is such a way so that this is going beyond these surfaces. And if that element size is increased by the factor of 0.2 or 20%, this will divide the element into two parts, like in this way. So in this way we capture the geometry properly. But here we set the value as a 0.05. 0.05 means 5%. Here by default is a 0.2. So if the element is increased from the boundary by the 5%, the element will be divided into the two parts. And this is what we usually do, that this is a solution for these type of the things when we have a very sharp boundary and that is not capturing that sharp corner. So we will set this parameter between 0 and 1. So I choose the value as a 0.05. Alright, so this is all settings we have done, and then dismiss. And then simply go to the compute mesh and select the option as a robust octree and click on compute, and make sure that in the input the select geometry should be selected as all, because some surface they are not visible here. So if you don't select them, so the mesh will leak and we get the problem of the mesh leakage. So this is not what we want to do. So make the selection as all and click compute. And if there's some old mesh, then replace this mesh. And this is the result after creating the octree mesh. And so you can see that these edges are there captured properly. And if I take a look on the mesh quality, this is right now is a 0.29. It's a volume mesh, and the minimum quality we should try is 0.3. And the second step is that now after that we have to delete the volume mesh, because if you take a look on the volume mesh from inside, if right click on the mesh and cut plane and manage cut plane, show cut plane, so you can see that if you take a look on the volume mesh, and as you can see that the volume meshing has the very steep changes in the sizes across the all layers, and that's the reason that we don't want the volume meshing to be done by the octree. And the advantage we are getting from octree mesh is that we are getting the surface mesh without much efforts. Just set the sizes and few more settings and just hit the compute button and you will get some mesh. And then delete this volume mesh. So from edit mesh we have the option delete volume mesh or the just mesh. So you can delete any element type. This can be line element, this can be shell element or surface element, and this can be the volume mesh. So just click here and you can delete the volume mesh here. And after deleting volume mesh, we are going to refine the surface mesh, and our target is that we should be getting the as possible as we can the highest quality. And so we strive for the 0.8. It does not mean that we will get this quality, but we start with some higher value and we let the software to try to maximize the value up to this value. So let's see what happens. Okay, so in the first system we have the value of 0.34, and also I want to see the surface mesh as we refine the mesh, and hide the surfaces from here, and any extra boundary and bodies, for example. And next thing is that we run with the Laplace smoothing and choose edge length. In the normal cases when we refine the mesh, for example, some common cases, we use a pure Laplace smoothing. But with these blades with the sharp trailing edge and leading edges, if you use a pure method, this will destroy the mesh elements on surfaces. And that's why for this type of cases, I recommend the value as edge length and apply. And when we apply the Laplace smoothing, the quality will not increase too much. Maybe it will reduce to some lower value, but definitely this is increasing the quality. And secondly, it is distributing elements evenly across the whole surface. So for example, if there is some more concentration of elements in some local region of the that surface, this command, this Laplace smoothing with the edge length, this will evenly smooth out and distribute them across the whole length or surface width. And then again without Laplace smoothing, so we start with without Laplace smoothing, then Laplace smoothing, and then we switch between these two methods, and the last step should be without Laplace smoothing. And when we stop this process is the point where we cannot get the higher quality further. So right now we have 0.37, then we start with again the Laplace smoothing, edge length, and then again without Laplace smoothing, and I will stop here. So you can maybe next 5 to 10 iterations you can be doing that thing, alternative options, Laplace and without Laplace. So I will stop here because I have to create some other commands also. So I stop here, and right now quality is 0.39, but you can get the further better quality with these commands. And now we go back to the mesh, and then from here we use the compute mesh method, and this time we use the quick Denali method. And the benefit of quick Denali method is that this will create the volume mesh with a very fine quality. And now you can see the volume mesh after Denali method, and transition between elements is very controlled, and we have refinement near the surfaces, and as we go into the free space, the elements are increasing, and the maximum size we will get is equal to the element size we defined here, which is the maximum element seed size. It's a 0.01. The next thing we will do is that we will create the prism mesh, and for that we have to select the surfaces where we want to have the prism mesh, and this is definitely around these blades. So select them. And one more setting I want to make here is that I want to set the criteria for quality to the lower value. So let's say I put the value as a 0.0001, and that is to avoid of creation of pyramid elements. If you go with the lower quality, this is okay with the fluent, but the pyramid elements, they are not suitable for the fluent solver. Although they are good for the CFX solver, but for the fluent, the pyramids, they are less favorable here. So try to reduce the quality of prism elements, and so at the expense that we don't want to get the pyramid elements. Again go to compute mesh, and this time to the last option prism mesh, and click on compute. And also I want to make one more setting is that I want to go to the advanced options, and from here uncheck the option for the stress step. Stress step means that if there's some problem in the prism meshing, this will reduce some layers in some locations. So it will not create by default there are 3 layers. It will not create 3 layers. So depending on the location and the problem areas, this may reduce to the 2 layers. In some locations we have the 3 layers, some locations we have the 2 layers. So we don't want to do it. So uncheck that option and then click on the compute, and just wait for the prism to be generated inside the volume. And after creating prism mesh, we can see that we have these prisms, and only volume elements we have here, they are tetrahedron and prism, and there are no pyramid elements here. And this is the effect of turning off the stair option. And second thing is that we have reduced the quality for prism mesh, and so it didn't try to create the pyramids. Thank you. And if you have any questions, you can ask me in the comments, or you can email me with the given email. You can find out from my social media account. Thank you.